3.4, number 33, volcanic lava fountains. Although the November 1959 Kilauea-Iki eruption on the island of Hawaii began with a line of fountains along the wall of the crater, activity was later confined to a single vent in the crater's floor, which at one point shot lava 1,900 feet straight into the air. Alright, so we got lava, goes up 1,900 feet. Good to know. And it's a world record. What was the lava's exit velocity in feet per second and miles per hour? And then it says a hint: if the initial velocity is the exit velocity of the particle of lava, its height, t seconds later, will be s equals initial velocity times time minus 16 time squared feet. Begin by finding the time in which ds dt equals 0. Well, let's find ds dt. And okay, when is that 0? Well, we can just make it 0. And if I solve for v sub, or initial velocity, v sub 0, it'd be 32t. Alright, so one way to write our initial velocity, it's going to be 32t. Alright, the other information that we know is that it goes 1,900 feet. And when it is at 1,900 feet, our velocity is 0. Okay, so if I plug in 1,900 feet into our equation, I can solve for v sub 0 again, so I add 16t squared. Okay, so this is when it's at 1,900 feet. This is when our velocity is 0. So in both times it's the same time. Okay, so we can set those equal to each other. And so 32t equals 1,900 plus 16t squared over t. And now it's some algebra. So whatever the square root of 1,900 over 16 is, t, let's see, I think it's 10.9. Okay, so if we go back to what are we looking for, we're trying to find the exit velocity. We found time when it occurs, so we could find our initial velocity or exit velocity. It's 32 times 10.9 is our v sub 0. 32 times that. Let's see if I have it written down here. 348.7. And that would be feet per second. And you could always change that to miles per hour. I think the question asked to make it miles per hour, but I'm going to call that good.